Hey class, so a few of you have been asking about question 5 on the homework, so I thought I'd give you guys a little homework video about it. So, what's the situation here? We got this sledding hill. We're going to assume that it's perfectly frictionless since we haven't learned about friction yet. And we're going to say that there's a sled here, and there's a person on the sled, a kid on the sled, sitting here enjoying herself sledding. Yay! Alright, smile because physics is in action. And then there's you up here, and you're pulling this person on the sled. Maybe you have a rope or something that's attached to the front of the sled. So you're pulling them up the sled. It's a little harder work for you, so you're not quite smiling as much. All right, so anyway, what do we have going on here? We're told that the total weight of the child in the sled is 500 newtons. So if we wanted to do a free body diagram for the child and the sled and everything, I'll do a different pick color here. You'd have the weight force going down. There's the normal force or support force from the hill, and then there's your pull force, maybe I'll call it P for a pull force, pulling the child up the hill. And so what we're told here is that the weight force, maybe I'll just list out what I know over here. All right, so we know that the weight force is equal to 500 newtons. And then we say, for simplicity's sake, let's assume the hill supports 4/5 of that. So that means that the normal force is 400 newtons. And so that means that you're just having to pull 100 newtons of the weight. All right, so again, we're making some simplifying assumptions here, but that seems reasonable. All right, so that's the general setup. On the question here, then, we're asked initially, what is the net force acting on this child? Well, if we make the observation that we're pulling at a constant velocity, we should be able to make the observation that the net force, according to Newton's first law, is just going to be equal to 0 newtons. All right. The second question asks us, how much upward pull force must you exert on the child? Well, you need to pull to support 1/5 of the overall weight. Okay, so another way to think of this, if you're confused by my picture here, if we were to take the weight force of the child here and we were to break it up into two pieces, you could break it up into one piece being the weight into the ramp and then a piece of the weight down the ramp. And the weight down the ramp is the 1/5. So your pull force here, the pull, must be equal to the weight down the ramp. They have to be equal and opposite to have a net force of 0. And so that's how I know that the pull force is equal to 100 newtons. All right? So that's the first couple problems here. We can box these up to help get you started. Part C then asks, how much work do you do to pull the child a distance of 220 meters up the slope? So again, that's saying that how much work do you have to do if the distance that you move this direction here, this distance here, if that's 20 meters? Well, we know that work equals force multiplied by the distance, as long as they're in the same direction. So the work, this is tricky. I'm going to do capital W here to differentiate from my lowercase w for weight. So the work we have to do is just going to be equal to our force that we're pulling, 100 newtons, multiplied by the distance that we're pulling it, 20 meters. All right, I'll let you guys do the math, but yeah, there you go. The next question is, how much work must you do to pull the child and sled to the top of a 50-meter hill? So now we have a situation where we're not talking about the distance diagonally, but we're a much larger and longer hill where this distance here is 50 meters. Well, there's a couple ways to go about this. You could figure out what the length would be using some geometry, but that seems like too much work. Work, get it? Sorry. All right, so what instead you can do is, according to conservation of energy, if you move the child up the hill a total distance of 50 meters, then you have increased the child's gravitational potential energy. And by the conservation of energy concept, we know that the work that you do is just going to be equal to the energy that she gains. So the potential energy final for the child. And we know the potential energy is equal to mass times gravity times height. All right, so you can calculate the work you did without even having to figure out the distance by just knowing the weight, mass times gravity's weight, of the child and multiplying that by the 50 meters up the hill that you moved her. Okay? So I'm going to stop here for now. Hopefully that gets you going. The rest of the questions actually end up being a lot more about conceptual ideas, and there's actually no additional calculations you are going to need to do once you have these first few parts figured out. So anyway, give that a go. Let me know if you have any questions, and yeah, I hope it helps.